All right, let's get into this deep dive. We've got some great source material here, looking today at HCF and LCM.
Yeah, highest common factor, lowest common multiple, foundational stuff, but our goal here using these sources is really to unpack them. What are they, how do they work, and maybe find some surprising places they pop up.
Okay, so starting right at the beginning, the sources bring us back to basics, factors and multiples. What's a factor again?
Well, think about it like this. A factor is a number that divides another one perfectly, cleanly. The source uses 3 and 18, right? 3 goes into 18, no remainder. So 3 is a factor of 18.
Got it. And multiples?
Multiples are the other side of that coin. 18 is a multiple of 3 because, well, you multiply 3 by an integer, 6 in this case, to get 18. It's like the results you get counting by 3 is 3, 6, 9. Yeah. Eventually you hit 18.
Okay, simple enough. But then the key word is common. The sources move to that quickly. Common factors for, say, 18 and 24.
Exactly. Those are the numbers that are factors of both. So for 18 and 24, let's see, 1 works for both, 2 works, 3 works, 6 works too. Those are the common factors.
And same idea for common multiples, like for 4, 6, and 12.
Yep. Numbers that are multiples of all three. So 12 is 4 by 3, 6 by 2, and 12 by 1. So 12 is a common multiple. Then 24 works too, right? 4 by 6, 6 by 4, 12 by 2.
Right, 36.
I keep going.
They do. And that leads us straight to the H and the L, the core ideas.
HCF, highest common factor. So out of those common factors for 18 and 24, 1, 2, 3, 6, the HCF is just the biggest one.
That's it. Simply the largest number that divides all the numbers you're looking at. So for 18 and 24, it's 6.
It's like finding the biggest possible identical tile size that could perfectly cover floors of, say, 18 units and 24 units.
That's a good way to think about it, yeah. The sources mention different ways to calculate prime factors and stuff, but the concept is that greatest shared divisor.
Okay. And LCM, lowest common multiple.
So going back to 4, 6, and 12, there are common multiples where 12, 24, 36, and so on. The LCM is just the smallest one in that list.
So 12.
Exactly. It's the smallest number that all your starting numbers divide into perfectly. The first point where their cycles meet, you could say.
Smallest shared outcome.
Okay.
Okay. Now, the source material pointed out something interesting about co-prime numbers.
Yes. Co-prime. Numbers whose only common factor is 1, like 16 and 25. Or the source mentions 9 and 80. They don't share any prime factors.
Their HCF has to be 1 then.
Right. And here's the neat part. The source highlights. For co-primes, their LCM is simply, well, you just multiply them together.
The product of the two numbers. Interesting.
Yeah, it tells you something about how unique their building blocks, their prime factors, are.
Which sort of leads into another really powerful relationship the source explores, this connection between HCF and LCM.
Oh yeah, that one's fundamental. For any two numbers, if you multiply their HCF and their LCM together,
you get the same result as multiplying the two original numbers themselves. Exactly. The source had that example, 189 and 297. HCF is 27, LCM is 2079. And sure enough, 27 times 2079 is the same as 189 times 297. It's a really cool property.
It shows they're really links, not just separate ideas. Okay, so beyond the math, where does this actually, apply?
Well, the source gives a great practical example. Problems with steps or intervals. Think about two people walking. One takes 80 centimeter steps, the other takes 90 centimeter steps. They start together.
When do their feet land in the exact same spot again? Like, when are they perfectly in step?
That's an LCM problem. You need the lowest distance that's a multiple of both 80 and 90.
Which the source calculates as 720 centimeters.
Right, 720 centimeters. That's the first point after the start where their steps align perfectly again. It's all about...
And the source material hinted at other things too, like problems involving remainders, finding numbers that leave a specific leftover amount when divided by different numbers.
Yeah, those puzzles often use HCF or LCM concepts to pin down the answer. It shows how these tools help solve very specific kinds of number problems.
So if we boil it down, HCF is like finding the biggest common ingredient, the largest shared piece.
And LCM is finding the smallest shared result the first time different cycles sync up.
Okay, so wrapping up this deep dive based on the sources, we've looked at factors, multiples, defined HCF, that biggest shared divisor, and LCM, the smallest shared multiple.
Explored that key link between them, the product rule, and saw how LCM, for example, helps figure out when things go inside, like those walking steps.
So understanding these really gives you tools to, well, break down numbers or find common ground, common cycles.
Definitely. It's about structure and relationships within numbers.
So a final thought for you, drawing from what the source material laid out. HCF finds the largest common measure. LCM finds the smallest common point of recurrence. Think about where else finding the biggest shared component or the smallest repeating cycle might be useful. Maybe not just with numbers, but scheduling things or optimizing workflows, or even just spotting patterns around you, something to chew on.